We shall do some problems which are there in the textbook. This is problem set of problems. What is this? Actually, in the expression P is equals to E into L square m power minus 5 g power minus 2. The quantities like E, L, M, G denote energy, angular momentum, mass, gravitational constant respectively. So we have to show that P is a dimensionless quantity, right? So first let us write what are the dimension formulas for that. E is equals to energy, which is ml squared t power minus 2. L is angular momentum, right? ml square t power minus 1. M is mass, simply m, and gravitational constant. You know that in the last class we have derived gravitational constant dimensions are m power minus 1 L cube t power minus 2. So we should substitute in expression P. P is equal to E L square m power minus 5 g power minus 2. So m L square t power minus 2 m L square t minus 1 whole square m power minus 5 m minus 1 L cube t power minus 2 minus 2. So let us elaborate it. M L square t minus 2 m square L power 4 t power minus 2 m power plus 2 L power minus 6 and t power 4. So m square m and cancelled. L power 2 L power 4 L power 6 L power minus 6 cancelled. T power minus 2 T power minus 2 T power plus 4 getting cancelled. You will get it as m power 0 L power 0 T power 0, which is dimensionless quantity. Okay, this is simple problem by substituting all the dimensional formulas in the given formula. Then we will solve that. Let us see another simple problem. Right. See, if velocity of light is c, Planck's constant h, gravitational constant g are taken as fundamental quantities, then express mass, length, time are the terms of these quantities. How to solve this one? First, let us try to write what are the dimension formulas of all these. C is a velocity, light velocity, LT minus 1. Next, H is a Planck's constant, H is equal to E by nu. If you write it, what is that? L square T minus 1. Next, inertial gravitational constant, G is equals to m power minus 1 L cube T power minus 2. So these are if you are taken as these fundamental quantities, you have to express mass, length, time. So if you want to express mass, m proportional to C power A, H power B, G power C. M is equal to constant C power A, H power B, G power C. Right? Now apply dimension formulas on both sides. M is equal to some constant LT power minus 1A and H value ml square T minus 1 B value m power minus 1 L cube T power minus 2 C value. Right? So compare powers on both sides. Right? M power B, L power 2B, T power minus B, M power minus C, L power 3C, T power minus 2C. Right? M is equal to K into L, L, L. L power A plus 2B plus 3C. M power B minus C and T power minus A minus B minus 2C. Okay. So now what is that? B minus C is equal to 1. A plus 2B plus 3C is equal to 0. Minus A minus B minus 2C is equal to 0. Now what is this? Solve A comma B comma C values using above expressions and substitute here. Okay, just you do it, then you'll get it as m is equal to, you'll get it as under root of SC by G. Just solve it. We'll substitute the values like this. You'll get H power 1 by 2, you will get C power 1 by 2 and J power minus 1 by 2, means C is equal to minus 1 by 2, you will get it. Just you solve it. Okay. Next, if you are taken as a, if you want length is, again you write it as length is proportional to C power A, H power B, G power C. L is equal to some constant C power A, H power B, G power C. Just again you substitute the dimension formulas on both sides. K into LT minus 1 whole power A, ML square T power minus 1 B, M power minus 1 L cube T power minus 2 C. So compare powers on both sides. Compare powers on both sides and find A comma B comma C values and substitute in the relation. Okay, just you do it. You'll get it as a length L is equals to under root of GH by C cube. You'll get it. Next, third one. Time is proportional to C power A, H power B and G power C. So time T is equal to some constant K, LT minus 1A, ML square T power minus 1 B, M power minus 1 L cube T power minus 2 C. Again what you do, compare the values, compare the powers on both sides. Compare the powers on both sides. Find A comma B comma C values, right? You will get it as T is equals to under root of GH by C power 5. You will get it, right? So you do the work on it. You'll find out the values of ABC and substitute. You'll get it. And we shall see other problem. Right. An artificial satellite revolving around the planet of mass m and radius r in a circular orbit of radius r. Using dimensional analysis, show that the period of the satellite is we have to show that is a constant K by R small r cube by G. We have to show that this. Right, how to solve this one? According to the Kepler's third law, the T square is proportional to length of the cube of the semi-major axis, semi-major axis. Sorry. T square is proportional to the square of the time period directly proportional to the cube of the length of the semi-major axis. So what is that actually? T proportional to A power 3 by 2. What is A here actually? What is A? What is that length actually here? Instead of length of writing length semi-major axis, we will write it as, this is called as R power 3 by 2 because here R is there. So T proportional to R power 3 by 2. What are the dependents here? The time period is proportional to r power 3 by 2. Time period is proportional to gravitational acceleration g power x, and time period is proportional to a capital R5 disk radius, this one. So combination, if you write it, t proportional r power 3 by 2 g power x r power y. So t is equals to some constant k, r power 3 by 2 g power x and r power y. So substitute all the dimension formulas. T is equal to some constant k, L power 3 by 2 LT minus 2 gx and L power y. So T is equals to some constant k, L power 3 by 2 plus x plus y, t power minus 2x here, 3 by 2 plus x plus y is equal to 0, and minus 2x is equal to 1. From this, x is equal to minus 1 by 2. Substitute this one, 3 by 2 minus 1 by 2 plus y is equals to 0. Then what you get, the y value, you will get it as minus 1. So we obtained x value and y value. Substitute here, you will get it. So t is equals to k into r power 3 by 2 g power minus 1 by 2 r power minus 1. Shall I write like this? K by r power 3 by 2 by g power 1 by 2. So k by r, this you write it as r cube by g, r cube by g. This is the answer that we obtained. Okay. Next we shall see other problems. State the number of significant figures. What is that? 6729. 6729. Significant figures are 4, 0.024. So these two are called as reading zeros, are not counted. Significant figures are 2 and 0.08240. Reading zeros are not counted. Simply contains, it is only having 4 significant figures. 6.032. It is purely 4. 4.57 into 10 power 8. It is purely 3. Right. So these are the simple calculation of simple significant figures. Now another problem. Fifth problem. A stick has a length of 12.123 centimeters, another is 12.4. If the two sticks are placed end to the end, what is the length? If they are placed by the side, just you add it, then you will get the total length. 12.132 plus 12.4. So 2, 3, 5, 24. So compare these two. After the decimal, how many digits are there? Here 1, here 3. 3 digits are there, 1 digit is there. So the least number of digits is placed in this one. So answer should also contain, after the decimal, only 1 digit should be present. So this can be discarded, this can be discarded. Answer is 24.5, of course, centimeters. This is. Okay. Difference. You find difference also. So find difference. 12.4 minus 12.132, let us say, which is called as 8, 6, 1, this one. 0.2638. So we will use the concept of rounding off. After the decimal, only 1 digit should be present, because the least number digits are possible after decimal is first number. So 0.8 can be cut to 7, 7 can be cut to 0.3. That's all. This is the answer. This is all the process is called as rounding off. Right. Next, each side of cube is measured as 7.203. What is the surface area? What is the volume of the cube to the approximate significant figures? So side is 7.203 meters. Of course, 4 significant figures are there. Total surface area is equal to 6a square. 6 into 7.203. So if you do calculation, what will you get? 311.29 meters square. But rounding off, 4 digits are there. It should also contain 4 digits. 311.3 meters square. Volume of the cube, which is equal to a cube, equal to 7.203 into 7.203 into 7.203. So all are having 4 digits. We should make the answer to be also 4 digits. So let us say 373.7 1 meter cube, which is also called as 373.7 meter cube. This is a final answer, rounding up to 4 significant figures. This is rounding of to 4 significant figures. Right? This is a simple problem. Next one, the measured mass of the body 2.42 grams, volume 4.7. So the error 0.2 0.01, 0.01 centimeter cube. Find the maximum error in the density. Okay. Mass is given, volume is given. Mass is equals to 2.42 grams plus or minus 0.01 gram is given. Volume is equal to 0.1 centimeter cube plus or minus 4.7 centimeter cube plus or minus 0.1 centimeter cube. Right, what is the maximum error in the density? So we will find out relative error. Density is equal to mass by volume. So the relative error delta D by D is equal to delta M by M plus delta V by V. So delta D by D is equal to, what is delta M? 0.01 by 2.42. What is delta V? 0.1 by 4.7. So which is called as and what is a percentage error and how to what is asked? Maximum error. If you do calculation, you will get it. What is a percentage error? So percentage error in D. So delta D by D is equal to 0.01 by 2.42 into 100 plus, we will also multiply 100. 0.1 by 4.7 into 100. So this is percentage error in D, which is approximately equal to 0.413 plus 2.127, which is again 2.54, adding of this one, which is percentage. This is a maximum percentage error which is existed in this one. So this is called as relative error, multiplying with 100, which will be giving us total percentage error in D. Okay. So this is another problem. The error in the measurement of radius of a sphere is 1%. What is error in the measurement of the volume? Right. V is equal to 4 by 3 pi r cube is the volume of the sphere. Delta V by V is equals to 3 into delta R by R. So delta V by V into 100 is equals to 3 into delta R by R into 100. So 3, what is the error percentage here? 1%, which is called as this one. So the error percentage in volume, which is called as 3%. So in that way actually we can see the many number of problems like that. Ninth problem. The percentage error in the mass and speed are 2-3%. What are the maximum error in the kinetic energy calculated using these quantities? kinetic energy is equal to of mv square. Delta k by k is equal to delta m by m into delta v by v. Delta k by k into 100, delta m by m into 100 plus delta v by v into 100. Right, this is 2 percentage plus this is 2 into 3 percentage. So 6 plus 2 8 percentage. That is the error which is present, which is about 9th problem. The last one, a 10th problem we shall see. If 1 mole of ideal gas of standard temperature pressure is occupies 22.4 liters molar value. If the hydrogen atom molecule is about 1 angstrom size of the hydrogen atom, what is the ratio of the molar volume to the atomic volume of the hydrogen? First, we shall find out molar volume atomic volume of the hydrogen. Okay, 1 mole contains, you know very well, 6.023 into 10 power 23 atoms. So molar volume which is occupying 22.4 liters. 22.4 into 10 power minus 3 meter cube. So atomic value means each molecule of spherical manner 4 by 3 pi r cube. Such many atoms are there, 6.203 into 10 power 23. But what is given, which is given as 1 angstrom as a, so pi into 10 power minus 10 meters r value, r is equal to 1 angstrom which is equal to 10 power minus 10 meters into 6.203 into 10 power 23. Right. Now molar volume to atomic value, which is equals to 22.4 into 10 power minus 3 by 4 by 3 into pi into 10 power minus 10 into 6.023 into 10 power 23. So you do calculations, and after that, which is about again 0.89 into 10 power 4. So this is approximately 0.9. into 10 power 4, or which is equivalent to 10 power 4. So this is about the simple problems. You try to solve other problems also.